Now let's talk about the application protocols, the protocols that work in the session, presentation, and application layers of the ISO-OSI model and in the application layer of the TCP/IP protocol. These protocols are such as the HTTP or HTTPS that offers the web services. The HTTPS is the secure version of HTTP. This S is for security. Or like the file sharing services, FTP or TFTP, file transfer protocol or trivial file transfer protocol, or the mail services, simple mail transfer protocol, SMTP, POP3 or IMAP, Post Office Protocol version 3 or Internet Message Access Protocol, or the DNS services, the Domain Name System Services. These are the protocols or example protocols that work in the application layer of the TCP/IP. Each of them has a dedicated port number. Each of them offers a certain service between the source and the destination, between the client and the server over the internet, to offer a certain service to the user of such protocols. Let's start by the HTTP. HTTP stands for Hypertext Transfer Protocol. It supports the web services. It supports the transmission of images, texts, and hyperlinks between the web server and the web client through the web browser. It supports all the www pages that can be transferred between the server and the client. It uses port number 80. The secure version of HTTP is HTTPS. S here is for security, and HTTPS uses the port number 443. HTTP is one of the application layer protocols in TCP/IP. FTP, or the File Transfer Protocol, uses port number 21. It has a built-in application in the MS Windows operating systems, Microsoft Windows operating systems. Many third-party programs can act as FTP server and client as well to transfer files between the FTP server to the FTP client. The web browser, any web browser, can work as an FTP client if you replace the HTTP suffix at the start of the URL with the word FTP. Then it will work as FTP client and can be able to transfer files. The email protocols. We can see in the diagram that the email client is contacting the email server through two protocols. One of them is for sending, which is the SMTP, and the other is for receiving emails or downloading email messages from the email server to the email client, which is the POP3. The communication between mail server X and mail server Y is done via the SMTP protocol, Simple Mail Transfer Protocol. The SMTP is the common language between the majority of the mail servers around the internet. Once more, at the client Y, the SMTP is used for sending emails from the client to the server, client Y to server Y, and the POP3 is used to download messages of client Y from the server Y. The POP3 or the IMAP, it depends whether you want to download the message through POP3 or to just access the message through the IMAP. The SMTP is the common language used by the majority of the mail servers, as we have said. It sends messages back and forth to other mail servers, and it is used to sending message between the mail client and to the mail server. The Post Office Protocol is for receiving and collecting email messages from the mail server to the client. It downloads the messages on the machine, so the user can work offline, can download the message at the beginning of the session, and then if the internet cuts, it can work offline. This saves quota on the server since the messages are downloaded from the server to the client, so the quota of the user can be emptied for other messages to arrive. Internet Message Access Protocol is another message to access the messages by the client on the server. It is just for accessing the messages, reading them. It does not download the message. It does not save the quota. It retrieves only the message header, allows the user to read the message, but the body of the message itself, is at the server side. So this is more commonly used if you are accessing your email from a machine that is not yours, from a machine that you do not want to download your messages on. The DNS protocol, one of the application protocols working in the TCP/IP. DNS stands for Domain Name System or Domain Name Servers in some written texts. The DNS resolves the domain name into IP address. For example, www.cisco.com is a domain name. This is a name that can be understood by the human, but the machine needs numbers, needs addresses to work with. So this resolution between names that are understood by human into addresses that are understood by machines is done via the DNS, the domain name system. The DNS server here matches the human address with the numeric address. The device uses numbers, understands only ones and zeros and numbers. So www.cisco.com is mapped into the address 198.133.219.215. Humans can easily understand names, machines can easily understand addresses, and the DNS acts as the resolution machine for resolving names into addresses. This is the DNS tree around the world. We can see that we have websites or domain names ending in .org, .com, .de, .is, .uk, and .anything. We have each country in the world have two letters suffix, like .uk, United Kingdom, .de is for Germany, and we have .org for organizations, com commercial, edu for educational, mil for military, and net for networking organizations. And we have some organization names that are governing the internet, like the IETF, Internet Engineering Task Force, and the other organizations that can work and manage the internet as examples of the domain names that can exist over the internet. We have here the www as the machine name that can be connected to IETF as the parent domain name, then .org. This forms the fully qualified domain name of www.ietf.org as a website. If we can see DNS in action, here we have a DNS client that contacts its local DNS server asking for what is the IP of Cisco.com. This local DNS server does not have the answers, but can ask a parent DNS about things that ends in .com. What is the IP of Cisco.com? And the parent can answer it with the IP address of Cisco.com, then the answer is transferred to the DNS client. Sometimes this local DNS server caches the answer for the sake of not asking once more for the previously asked domain names, and can answer about www.cisco.com from its cache in the second time it is asked about from any other client than the first client. We have also a very well-known and famous protocol working in the application layer that is called the DHCP, Dynamic Host Configuration Protocol. It's an important protocol in the configuration of the TCP/IP parameters inside any machine. If a client on a certain network boots and moves to be up on the network, it sends a DHCP client broadcast, a discover message that is read by several servers over the network that he is connected to, several DHCP servers. One of the servers sends the DHCP server broadcast offer message, which means that he offers the client some of the TCP/IP parameters that he can take to start and work over the internet. What are these parameters? These parameters are the IP address, the subnet mask, the default gateway, and the DNS mainly. The DNS server that he can contact to communicate over the internet. Then the client responds with the request message for leasing and asking for these parameters. The offer message says that I'm a server, I'm a DHCP server, I can offer you these parameters. Then the DHCP server finalizes the exchange with acknowledgement message. Finalizes that this client has reserved this IP address, this subnet mask, this default gateway, and this DNS, so that he cannot repeat leasing the same IP address to other machines. Otherwise, there will be a conflict of IP addresses between two machines, and this is forbidden. No two machines can have the same IP address over the same network. So, what is the main benefit of this DHCP? It saves the efforts of the network administrator that is used in configuring several machines with IP addresses, subnet mask, default gateway, DNS servers. It saves this effort and makes a machine does this task. Of course, the machine does not make the mistake of the IP conflict, does not make the mistake of assigning the same IP address to two machines. The DHCP as a protocol is very commonly widely used over the networks to lease IP address, to distribute IP addresses over several machines on the same network, and to save the effort and to save the mistakes that humans can do by conflicting IP addresses. By this, we have searched some of the application protocols working on the application layer of the TCP IP protocol suite. Thank you.